The key insight was the majority of transactions on public ledgers do not conflict with each other and have no reason to be audited against each other. And as soon as you can break the need to process things sequentially, you can create a system that can scale linearly. You have to have an entirely new approach to how you store your data, how you validate your state, and how you submit your transactions to the ledger. And that required a full stack approach to do that, which is again why the Radix has taken the full stack approach, is because that's our secret weapon to enabling linear scalability as well, because it all had to be built in with this idea of cross-shard atomicity in consensus.
Welcome to Just the Metrics podcast. In this episode, I'm having a conversation with Piers Ridyard. Piers is CEO of RDX Works. RDX Works is a core company building Radix protocol. Radix is a distributed ledger network, which is aiming to build a linearly scalable network that also provides secure user experience and also an enhanced developer experience. If you look at the current blockchain landscape, there are two different kinds of blockchains. The one that are extremely decentralized but slow and expensive, like Ethereum or Bitcoin, and blockchains that provide a fast execution environment like Solana or Sui, but also making some trade-offs regarding the decentralization or the scope of participation in that network. In that context, the path Radix is pursuing is extremely interesting in the sense that it is aiming to achieve linear scalability. So this is a concept that we digged in during this conversation, and we also talked about Scrypto programming language, the native asset standard of Radix, and much more. This conversation was extremely informational, and I hope you'll all enjoy this conversation. And without further ado, let's dive into this conversation with Piers. So welcome to the conversation.
Thank you very much for having me.
Thank you for being here. The core topic that we want to discuss during this podcast is Radix and Radix's approach towards building a secure and linearly scalable platform. That is not such a common, like a pitch in the blockchain space. It's very much modular, and that kind of building, it's become like a major part of that blockchain space is going that way. But you are coming with this full stack approach. So before we go into the core Radix topic, the most important thing, like I always feel like it's very important to know about your personal journey in the blockchain space, what motivates you, because it's not an easy place to build stuff. So you need some very strong intrinsic motivation to get yourself going. So could you please tell about your personal journey?
Yeah, I think that my journey into blockchain, I got into Ethereum in like 2014, 2015. And it was just when the Ethereum network was getting started. And we were, and me and my friends, we started mining on essentially on the test network before Ethereum went live. And I think it was like 1/5 or 1/10 mining rewards. And I got into it purely from the point of view of, I had a background in consumer electronics, and my friend had said, let's mine Ethereum. And I was like, okay, cool. And I started diving into things like the Dagger Hashimoto hashing algorithm, and from there worked out what hardware we needed and started mining the Ethereum blockchain. And that was really the sort of the start of me getting into crypto. And I just spent a decent amount of time just hanging out in the space. I went to a lot of the early Ethereum meetups. I went to sort of the early dev cons that they had, and spent and I would invested in the DAO. Was involved in debating around the DAO hack fork that sort of was the fork that created Ethereum Classic and Ethereum. And it was a really interesting time to start to understand what this technology was and what made it important. And through that, I ended up meeting some really interesting people. And one of the people I met was Dan. And Dan, when I met him, founder of Radix, like impressed me with the breadth and depth of his knowledge and understanding. I think that's fair to say. And he was an incredibly exciting person to talk with, because his views were also so different from the received wisdom of what it would take to create a scalable platform, what it would take to build a network that people could, everyday people could use. And that contrarian view combined with his dedication meant that I sort of continually was attracted more to what Dan was building than what I was seeing in the Ethereum space or the Bitcoin space or stuff like that. And so there's a bunch of stuff that happened during this period. I started a company that went through Y Combinator, specifically focusing on blockchain technology for insurance companies. And ultimately, that company was acquired by RDX Works, which is the core developer of Radix, and that's how I became CEO. But it was, for me, my journey into the crypto space was, I suppose, incentive-driven at the start. Hey, there's this thing I can come and mine and potentially make some money doing so as like a side thing, as a hobby. But it was the idea space of crypto that sort of led me to stay and get so excited about the opportunities and then the technology that can then unlock those opportunities.
Like when you start building, when you start getting involved in Radix, what was the core part that attracted you, in the sense that what end goal was were you trying to achieve by building such a protocol?
Yeah, so at this point, I had already accepted that smart contracts were going to be an essential part of how the world was built. Having a background, somewhat of a background in finance and in law and in engineering, I had already seen in building sort of different businesses before I joined Radix how manual the whole financial process is at almost every level. At JP Morgan, I was watching back office processes that were literally hand typing or hand checking transactions from one system in another system. And at the investment banking level, where you got front office, majority of calculations for some pretty like large financial instruments, maybe like multi-billion-dollar bond issuances, also being done by hand on an Excel spreadsheet, and that Excel spreadsheet being your source of truth for everything. Like all of those things just felt crazy that in the day of the internet, you would still be doing that kind of stuff for the majority of the way that the world transacted. So I saw smart contracts as inevitable, and I saw the idea of digital assets being the main way in which we transacted as also being inevitable. It's been in science fiction forever, this idea of the digital credit and the fact that money would be entirely digital. That's in every single science fiction movie. No one's got cash, right? They've either got this random material that is valuable, which is like quasi-gold, or they have credits. So obviously the world is going to be transacting digitally in the future. And so the idea that you're going to have totally digital money, and the idea that all of finance is going to need to move to a programmable ledger, like those two things were already well embedded in my brain at that point. The next question was, is the technology that's currently being built actually going to achieve those things? And what, importantly, if you project forwards, what are the prerequisites for a system? If you were sitting here today and saying in 20 years in the future or 50 years in the future, everyone's going to be using a single piece of infrastructure like the internet, but for transacting. And that single piece of infrastructure is going to look like X. What would you say X needs to be? You'd probably say similar things to the internet. You'd say it needs to be able to scale without there being an upper limit to its scalability, because we have no idea how big it's going to be. People 20 years ago probably wouldn't have predicted the amount of bandwidth that an individual, let alone the world, consumes. But they had to build the internet protocol in a way that meant that it would never have bottlenecks. So you have to have a protocol that is able to scale without bottlenecks. The next thing is you have to have a programming language that is actually built for the new paradigm. A lot of people forget that JavaScript was created for the internet. When the internet arrived, there was no way of making web apps, really. You could have like Java applets, but really like making code run user side, you needed this new programming language. So JavaScript was created. And so is the programming language of today going to be the programming languages of today going to be the programming languages that we use 50 years from now, 20 years from now to be describing Web3 and DeFi? Absolutely not. It's very unlikely. There's going to be a dedicated programming language. Every single app, every single new platform that's come along, even if they are traditional, have also had their own programming languages. Apple created Swift specifically for the iPhone, specifically for making apps. Android, Kotlin, right? So like every platform has eventually gone, we need a programming language for the particular paradigm that we're building in. And so you need a programming language that's built for the paradigm and that developers, crucially, that developers find easy to use, that actually is powerful and solves problems for those developers. And then the third part is that everyone has to be able to use it. You need the Netscape Navigator moment. You need the piece of enabling user-side technology that enables people to actually be able to access these platforms and understand how to use them intuitively. Like my favorite expression around like consumer experiences, you didn't need an operating manual to use the iPhone, and you don't need an instruction manual to use Instagram. But
yeah,
if you put someone in front of MetaMask who's never touched it before, or almost any wallet experience, like it's just not good enough. It's not even close to being good enough to being mainstream ready. And so those were the problems that I saw once Dan had solved or worked out how to solve the scalability issue. The other two issues, like as long as we could solve those, you had an unbeatable platform. You had something that could actually bring Web3 and DeFi to the mainstream. And that's always been my motivation. Is this is obviously going to be magic, as in Web3 and DeFi and smart contracts is obviously a completely new paradigm for humanity. How can we bring that to humanity in the fastest, most effective way? And it's solving those three problems.
Yeah, and you are on point. And like blockchain platform have been in existence for almost 1.5 decades now, and we don't have particular thing that you are describing. And in that sense, this full stack approach of Scrypto, like creating the most favorite analogy when I read about Radix is this game engine approach of, could you talk about that particular, that's the best analogy I have found about Radix, just I found the most interesting. And what is this game engine approach?
Sure. So like our understanding of the crypto space was there's this gap that I think a lot of people don't realize there's a gap in crypto. That is the gap of how standards emerge in crypto, right? So you have this very messy process by which new token standards emerge. So ERC20, ERC721, ERC404, any of these ERC standards that create new token types. And once you create this new token type, you then have to go and get that adopted everywhere. You have to get the custodians to integrate the new token type. You have to get Ledger to understand how to sign the new token type. You have to get the wallets to integrate the new token type. You have to get smart contracts to understand how to interact with the new token type. And this is quite low level, but it's required because until you have that standard adopted by everyone, or until you've passed the point where everyone has adopted the standard, you can't actually introduce new functionality to the system. Now, what we realized is that there's essentially two layers of abstraction that are important in DeFi and Web3 rather than one layer. Most people go, okay, we have a smart contract programming language. Let's say it's Solidity, or in Solana's case, Rust, or in Sui and Aptos's case, Move. And in this smart contract programming language, you can define anything you want. And we're not going to enforce any kind of like rule set or standard in how you define it. It's just completely open playing field. And the computer game industry was similar, right? Like when the computer games first got started, people would go out and they would build a computer game. They build it however they want. They go, okay, I've got this much memory space. I've got this much, I assume this much RAM. So I'm going to build a physics engine and a rendering engine, and I'm also going to build the game engine, like the game engine for my game, and I'm going to build all of the things all together as a big mesh. And then I'm going to have to work out specifically how that runs on every piece of hardware that I want the game to go out for. And that made it very difficult to build games because everything was starting from scratch. Every single game was in this open new file, write your first line of code. The thing that changed everything for the game industry was the game engine, but the standardized game engine. So Unreal and Unity created these game engines that gave all of these low-level pieces as standardized formats, as standardized components. They went, here's a rendering engine, general purpose rendering engine. It will work for your game. It will work for any game. Here's the physics engine. And they would then go into all of the low-level optimizations and squeeze all of the performance out of it. And then these game developers didn't have to worry about all the low-level stuff. They could just go away and build the thing that made value, which was the games. And that's when games went from like cottage industry to bigger than music, TV, and film combined. Like the games industry is defined by the games engine. Now, in DeFi and in Web3, you see the same pattern. The same pattern is that there's a bunch of primitives that right now everyone defines from scratch every time. Like anyone who has tried to issue a token themselves on Ethereum knows that if you're going to build a token, you need to go and get your smart contract for your token audited before you issue your token. Like, why is that? That's because tokens are not primitives on the Ethereum network. The Ethereum network doesn't understand what a token is. You have to tell the Ethereum network how your token works as well as what the parameters for your token is. And also your token maintains the balances, all of the record of all of the balances. Ethereum doesn't know how many USDC tokens your wallet has. The USDC contract knows. And so your wallet has to talk to the USDC contract and say, hey, what's my balance? Not go to the network, hey, what's my balance of this token? So like on most networks, tokens are not really tokens. Tokens are actually just balances within a smart contract running on top of a network. And then you can say the same thing about accounts and the way that accounts are implemented. You could say the same thing about how permission stacks are done. And you can say the same thing about how things like swap logic is done. Like all of this stuff is actually repeated, like continually repeatable, useful things that every developer who's building Web3 and crypto has to do. They have to hand-roll themselves and go through all of the audit process and make sure it's all secure. And it just takes forever. And that was the same with the games industry. With Radix, what we did is we created the Radix engine. The Radix engine has all of these low-level primitives defined in the same way that the games engine created all of these low-level primitives defined, has the concept of accounts defined in a standardized way. So all accounts behave in the same way. It has the concept of tokens and NFTs built into, as a framework, built into the Radix engine. So any token you create instantly is recognized by the wallet. And at the moment you send it into a contract, the smart contract is able to receive it. The smart contract doesn't have to be configured to add new token types. The wallet doesn't have to be configured to tell it that this new token existed that didn't exist before, because tokens are native aspects of the ledger. And you also get a huge amount of security through this as well, because a lot of the security problems that come in as a result of how you have to hand roll the way that you interact with these standards. Whereas on Radix, because all of that is built into the Radix engine, that's not true. And so Scrypto becomes a much simpler programming language to use. Scrypto is the programming language on top of Radix. And now you don't have to worry about all of the low-level stuff. All you need to worry about in Scrypto is describing the business logic, the actions that you want to happen. So if you want to create Aave or Uniswap's like 100 and something lines of code in Scrypto versus 750 plus lines of code in Ethereum. Big part of that is because all of the low-level stuff is taken away from you. You don't need to worry about security. You don't have to worry about executing correctly. You just have to worry about going, this is the logic that I want to be when one token is swapped for another. And that will then work incredibly reliably and incredibly robustly using Scrypto and the Radix engine.
It's like, like combining three different aspects, like a user experience, developer experience, and along with that scalability. And Scrypto is an extremely developer-friendly programming language. I have read through the opinions that people wrote about Scrypto, and it was fantastic. So, but from an adoption perspective, how difficult is for a blockchain specific programming language get adopted by developers? Because I think the blockchain space is a bit more complicated. So how are you planning to break this pattern? How are you planning to bring new developers from a developer adoption perspective?
Sure. So, I mean, we started our developer adoption a long time ago. Like the Scrypto, the programming language, was created between the years sort of 2019 and 21. And over that time, we spent we interviewed about 1,000 DeFi and Web3 developers around all of the problems that they were facing building using existing programming languages like Solidity. And we kept iterating on a programming language that was as easy as possible for new developers to come in and use. Because our whole principle has been, the entire crypto space today, there's about 25,000, maybe a bit more, full-time crypto developers. There's 25 million developers in the world. So what really matters? What matters is developer adoption, not convincing developers in one camp, say Solidity, to come across and build in our camp. It's much more about going, how do you give tools to developers who want to come into Web3 crypto for the first time to then be able to go and build things that they can imagine? Because the crypto space isn't going to grow if we're just competing for the same blood. It has to be, how do you expand the pie?
Yeah.
And so then between the years 2021 and 2023, we focus very much on building our community, and the way that we build the Scrypto community is grassroots. You start with the principle that you have to find your starting community. You get continuous feedback from that starting community and you grow it from there. And we've seen an incredible growth in the Scrypto community over that time. We've had over 20,000 downloads of the Scrypto programming language. We've had like over 100 open source implementations of all of the functionality that you see in Ethereum. So if you want to see open source Aave, open source Uniswap, open source Synthetics, open source MakerDAO, on Radix, people have done it for fun, using our programming language and open source those examples to help people understand how to use Scrypto. We've done grant programs, and we've seen as soon as the network went live in September last year, we saw a large number of dApps launch immediately. And we went from, 0 to $25 million of TVL within a couple of months. And that's before there's trustless bridging across the Radix network. So the answer to how do you build a developer community is slowly, actually. Like, it requires you to continually be bringing in new people and getting them excited about what's possible to build in Web3. And out of any place that I've ever seen, Radix is the best place to get started building in Web3 because of Scrypto and the Radix engine. You asked about liquidity and stuff like that. It's interesting, like, most developers that we've worked with and that we've seen don't start by going, how can I make $1 million? How can I make $1 billion? How can I get hundreds of millions of dollars of liquidity? That's not where developers start. Developers start by going, hey, I've heard about this Web3 thing. It seems interesting. I should probably learn some more. What's the best materials to get started? They're not going, which ecosystem's got the highest TVL, which ecosystem's got the biggest market cap. This is going like, where's the right place for me to start learning this? And you can see that in programming, for example. Python was not a big programming language for a very long time. Why did Python become big? Python became big because it was the easiest place to get started programming. And a lot of people got their start in Python, and then eventually they were like, I'm gonna build using Python, right? And that's the approach that we're taking with Scrypto, is here's the best place to get started in Web3. If you actually are serious about understanding what Web3 is, that's what matters to building the pie. And that's what our entire funnel is built around.
Is there some application that you imagine that would explode in the next 5 years that would bring a new group of users to Radix?
It's an interesting question from the point of view of that I'm relatively unopinionated about what is going to be successful on top of public ledgers. What I'm more opinionated on is what is necessary to make sure that applications are successful. And what is necessary to make sure applications are successful it's easy to build, you have robust security, and your users have no problem in onboarding. Those are the things we focus on, right? It's easy to build, robust security, it's easy to onboard your users. Like when we were speaking with some of the top DeFi projects in the Ethereum space, their number one problem was that their bounce rate was like 99% from someone being like, oh, I want to put money into Aave to actually being able to convert. So your biggest problem for projects is often the user onboarding component. And for us, that's the Radix wallet and the transaction manifest that makes everything human readable. And it's giving those tools to creators to be able to go and do what they do best. But as to like what's going to be big in the next 5 years, we can absolutely say that payments is going to be big. Like digital payments for putting stable coins are going to reach. We're currently at $100 billion for USDT and $30 billion for USDC. We'll probably be 10x that in the next 5 years, maybe more. And much of that will be starting to reach out into everyday people's lives. So you'll see more people in developing worlds as well as in developed worlds deciding, like Venmo's huge in America. USDC, there's no reason that USDC won't be big in 5 years' time. And from the point of view of new applications, like it's going to look a little bit like what in Web 2 translated into Web 3 from a consumer side. So gaming, computer gaming is going to be big. Social is going to be big in some way. There'll be some overlap with DAOs and the concept of DAOs. And then in finance, like everything that you see in finance today is faster, cheaper, that on top of a public ledger. So FX markets, derivatives markets, credit swap market, interest rate swap markets, securitization, like all of that stuff. And what is currently the real world asset category is going to increasingly come onto the blockchain. But I don't think any of this is considered to be new. Like a lot of the good ideas about what is going to be public ledgers are going to be used for has been rehashed a lot since the crypto space, the smart contract space started in 2015. A lot of the ideas that were being talked about by the Ethereum community in 2015 are the ideas that are being mined today for new applications. I think the one area that I think is the joker card here is AI, and what's AI's interaction with the blockchain space going to mean for crypto and the space as a whole. But you were saying like Radix is a DeFi engine. It's not really a DeFi engine, it's a Web3 engine. Like all of the things that we're describing describe the elements that you need for Web3. If you're creating Web3, you need to have the concept of tokenization, the concept of accounts, and the concept of users being able to interact with applications built using Web3. Like all of that is part of the Radix stack. I think there is, as I say, I'm not opinionated about how people use the platform. I'm just opinionated about the tools that they need to be successful. And that's what we focused on.
Yeah. And you talked about AI and blockchain. How can AI or AI-based applications leverage blockchain capabilities? Or what are the opportunities you are seeing there? Or like what are the developments that you are seeing in that space?
I don't know. Like nothing that really convinces me yet. I just know that when a new technology comes about, there's a period in which people are working out how that new technology is applied to different industries. I can see that there's going to be a use case for agent-based payments in AI. I can see that there's going to be a use case for access to data and data sets using AI and blockchain. But I don't have a clear opinion about. I can reiterate many of the things that people are saying. AI might be useful for blockchain, but I don't see a clear cut use case in the next year is going to mean that blockchain and AI blow up. I think that AI is going to blow up first. The next thing that's going to be important is how AI systems interact with each other and are paid for from the point of view of like massive scalability of access to data sets, things like that.
Moving on to the next topic of this comparison of TCP/IP stack with the blockchain. So there's this two different approach in blockchain space right now. Radix is building a full stack approach, having everything natively built from ground up. And if you look at other platforms, what's happening in Ethereum Celestia space, people are taking SV and putting on top of Ethereum as well as Celestia and building like a very novel platform there. So how do you see this your full stack approach with this modular approach happening on the other side?
Yeah, so modular versus full stack has been a long running debate in technology since the time of the first created. Like ultimately what you're saying is, do I want there to be many microservices for a thing, or do I want the thing to be running in a monolithic way? When you're talking about a protocol, the thing that's most important is the protocol is efficient, the protocol is scalable, and the protocol has deterministic execution, right? And as soon as you go into the modular world, you have a lot more moving parts, and so you have a lot more ways in which it can go wrong. And you can end up with something being much more expensive than it would be otherwise. So if you look at microservices architectures are actually moving out of favor, or have been moving out of favor for quite a while amongst Netflix and all of these sort of like top companies, because of the complexities, the inherent complexities you come for going, well, this bit does this thing, and this bit does this thing, and this bit does this thing, and then all of these things have to communicate to each other. And none of them have really been built to integrate. They've just been built on the idea of there being these interfaces that things can communicate over. That doesn't mean that you don't have, a lot of the time the question is, where do you need modularity? and where do you need an approach that is as efficient as possible. And our contention is that for your execution layer, for where consensus occurs, and ultimately for where settlement is occurring, you want that bit to be as deterministic, as safe, and as scalable as possible. If you're talking about how can you build applications on top of that require more computation than is available via smart contract, yeah, sure, then you can add on modularity from that point of view. But I think what a lot of people are doing is they're reaching into quite deep into the stack, where they're going, okay, we'll propose a builder separation, and then we'll have a completely different network for data availability, and then we'll have a completely different stack for sort of execution, and then we'll have a different way of reaching finality. And while that creates a lot of hype for people to go, oh, cool, more networks, more tokens, more things to debate about, you lose that single-minded focus on how do you build the best system for the thing that you want to achieve. And in this case, the thing you want to achieve is smart contract execution. And when you want to do that, the best ways of doing that in a system is to get as close as you can to fully integrated. And you can see that in computing. Like the closer you are to bare metal, the higher your performance. The further you are away, the more abstraction layers are you away, the more expensive any particular operation is. And so you can think of the Radix engine and the Radix stack as like having a high performance system running in C or assembly. And then you can think of the modularity system as having a JavaScript stack combined with a Java stack, combined with a Go stack, combined with a whatever, like this mishmash of all these things. And it's going to end up being unperformant and problematic, and things are going to constantly break. Even if that isn't true, you also get liquidity fragmentation. You don't have a single unified layer for objects to be able to move seamlessly between places. You have these constant bridging problems. You have these constant fragmentation of different marketplaces. And you take away one of the big things that makes DeFi special, which is composability.
Yep.
Like the whole point of DeFi and Web3 is I can have 5 different applications that can all be called in one call, and they can either all execute or fail. In the modularity framework, you have all of these, you either have locks, or you have to reach consensus on one bit of it before you then reach consensus on another bit of it. And you have all of these dependency chains that end up being built up by trying to make these applications work on top. So from a tech point of view, yeah, it's cool stuff. From an application building point of view, complete nightmare. And from a user point of view, also a complete nightmare. I have to understand all of these new technologies rather than just being like, I want to do this thing, I connect to this one thing, and then once I connect to this one thing, I'm able to do all of the things I want. If the internet was modular, rather than you have the sort of like the single TCP/IP stack that you communicate over. That enforcement of a low-level standard that's highly performant for all systems that want to communicate with it has huge advantages for the world versus a modular approach. And so that's why I think the modular approach is, I don't think it's wrong from the point of view of modularity. It can be good, but it has to be at the right level of the stack. And I think that everyone is reaching too deeply into the stack and applying modularity to it, which is just going to create a lot of breakages and a lot of inefficiencies and a lot of costs and a lot of user pain.
I was using Farcaster and the base L2, and then I wanted to buy a NFT from OpenSea, but then I had to send ETH to the Sora L2, but from my Coinbase wallet, I'm not able to bridge to Sora. So I was like, oh my God, this is horrible user experience. And I'm talking about last week, this seamless user experience of a single platform, like what you envision with Radix, it has incredible amount of value from a user perspective. And that is lacking very much in this current space. How do you look at this emerging platforms like Move programming language, which is gaining a lot of traction recently? Like 7+ platforms have already adopted different versions of this particular programming language. So how do you see Move compared to something like Scrypto or object-oriented programming of Sui compared to Radix's Web3 engine approach?
Sure, everything is defined at the programming level in Sui, in Aptos, in any of the Move VM implementations. You don't have this concept of, hey, I have these native objects that are implemented at the level below the programming language that enforce standardization of components, tools, and objects. In Sui or Aptos, I define a new token type, and I define the logic that's in that token. And when I do that, new token essentially is a complex object. I now have to, I don't know whether or not you have to go and add every single token that exists in Sui to the wallet. I actually don't know whether or not they understand that. I haven't looked that deeply at it. But from the point of view of the platform, there's no such thing as a concept of a particular type of token. Every token is unique on Sui, and every token you are essentially defining all of this logic at the programming level, which goes down to all of the problems that I was talking about before when you don't have this enforced standardization across the platform for how something should behave and what something is. So on Radix, when you create a token, you're asking the Radix engine, you're saying, hey, this is my token definition. And the Radix engine will then pass you back that object. And now the object is a native object of the ledger, which means that anything I pass it to understands what it is because it's following the Radix engine framework. And any wallet that I send it to, I can see not just that I own the token, but also the metadata about the token. Oh, this is a recallable token. This is a burnable token. This is a freezable token. And so the main difference between Scrypto and Move is that Move has to do all of the work of the Radix engine plus all of the work of Scrypto. In Scrypto, you just have to do the work of defining what you care about happening on the ledger. So the amount of code you have to write, the amount that has to be secure, the amount of things you have to think about when it comes to security, and therefore how quick it is for you to be able to build something, there's still a huge difference between the Move approach and the Scrypto approach. What's more is because the Radix engine is natively embedded into the Radix ledger, it's also incredibly performant. So the amount of scalability you're able to squeeze out of the execution time for the programming language is much, much higher when you're using the Radix engine native components. Think of it as co-processors on a CPU or something like that. You have all of these extra components that are very high performance because of how low level into the platform they've been implemented. So you've got better developer experience, you've got much less code to worry about, you have much higher security guarantees around what the objects you create on the ledger are going to do and how they behave. You have much better user experience that comes out at the end of it. You have much more efficiency when it comes to execution time. And you have the fact that we were able to build all of that into the scalability approach of Radix so that you have this linear scalability that's possible as a result of how we've engineered the Radix engine and Scrypto. I'd say those are headline why I think that what the difference between the two approaches are.
Yeah.
But, that all said, I think Move's cool. Like, I remember when Move came out of Facebook ages ago, we had a good look at it and we thought the approach was really cool. It's an engineer's wet dream, but it ends up creating much more difficult to implement systems when you're trying to actually implement a real application, which is why we ended up with Scrypto and the Radix engine versus the Move approach.
Do you see any merit in this platform agnostic way a program can be implemented on different type of ledger architectures?
There's no such thing as platform agnostic programming in crypto, really. If I create something in the EVM and then I want to build it on Solana, I have to go and re-implement it in Rust, often using Anchor as part of the stack. And then if I wanted then to put that into Move, then I have to re-implement it in the Move way. They all have their own specificities around how the architecture works. Some of them you have to think about consensus itself. If you're thinking about like Plutus and Cardano, you have to think about state handling in your programming language. So if I created something in Aptos Move and then wanted to port it to Sui Move, I would have to re-architect my application. They're not the same implementation. Aptos have taken a bunch of decisions about how you have to use their programming language. Sui have taken a bunch of very opinionated opinions about how you have to use their programming language. They are different implementations. I don't know about the other ones you've spoken about, but they will have chosen a flavor of Move, and it will be probably the Aptos Move or the Sui Move, or they may have taken the original Facebook Move. And the problem with all of that is that it doesn't actually create the agnosticism. What would be agnostic is if people adopted the Radix engine and put the Radix engine onto different platforms And then you would have an agnostic basis for how you build your platforms, because you have the framework by which you recognize what accounts are, what objects are, and what permissions are. And once you have that standard, then your architecture of your programming looks the same. So on Radix, you don't actually have to program in Scrypto. We can in the future add other programming languages that are other than Scrypto that use the primitives of the Radix engine, and those would still function on the Radix network. But your agnosticism is at the level down. Your agnosticism is in the how you architect smart contracts, and then what your programming language what primitives the programming language uses to allow you to do so. And I think Radix is the only network where that is enforced at the network layer, which creates this enforcement of standards that we were talking about before. Yeah, I think the crypto space has got a long way to go before we get anywhere like agnostic programming in paradigms. But I think the only route that you could go in agnostic programming paradigms would be the Radix route, where you adopt the Radix engine as your underpinning way in which you create your smart contract architecture. And then you can adopt other programming paradigms around that if you wanted to. But we created Scrypto because we wanted it to be as easy as possible to people to adopt it. But yeah, in theory, you could re-implement Scrypto in Python or re-implement it in Move or whatever, but you would have to adopt the Radix engine to be able to do that.
And finally, about scalability. So the main characteristics that sets Radix apart from all other platforms is basically this linear scalability without any like beacon chain kind of structure or like the coordinating chain or something. It's like you add more resources, it will scale. So from that perspective, how could you talk about the scalability path that Radix is taking, and if it's possible, like where is it right now? I'm regularly following Dan's experiments with this testnets and community participation and stuff like that. Could you talk generally about the scalability path Radix is taking in comparison to others?
Sure. This is a long conversation, and I don't know if we'll have time to cover it all in depth right now. But the underlying principle of Radix, from a scalability point of view, is that most things that happen on top of a public ledger can happen in parallel, because most things on top of a public ledger don't conflict. If I'm sending a transaction to my mother and you're sending a transaction to your mother, we have the same mothers, we're not the same people, those transactions are not going to conflict. And actually, most operations on top of a public ledger are non-contentious, non-competing transactions. You obviously get contentious competing transactions on particular assets, on particular, DEX pairs at particular times, but generally speaking, most transactions are non-contentious, non-competing. Dan's insight here was you can use the data structure itself to help you separate out what is connected and what is not connected. So if you say the network itself is going to be sharded into 2 to the power 256 shards, which is, something like close to the number of the atoms in the universe. It's a very, very, very large number. You can then go, well, let's map the data deterministically to that shard space. So let's say, okay, well, my account maps to shard, my personal account, my wallet, my account maps to shard 500, and your one maps to shard 1000, and your mother's maps to shard 1500, and my mother's maps to shard 750, right? Now we know if we then have validators on top of that, and the validators are validating the network and are running all of these different shards, because the validators are also mapped deterministically to their shard space, which changes over time. You have net validator shuffling, but because they're deterministically mapped at any given time, me as someone who's doing a transaction would be like, hey, I'm on shard 500. I know that these validators are responsible for validating shard 500. I'd like to send this transaction, please. And then the validators can go, oh, that transaction is touching shard 750 for Piers' mother. So then they'll get the validators involved in that as well. And then those validators will be able to reach consensus on whether or not that transaction was validly sent from shard 500 to shard 750. Because let's say you sent your transaction exactly at the same time, because your transactions do not touch the same shards that my transaction does, there is no reason that those validators have to run those transactions in series. Let's say that the validator set was exactly the same for both of them. In a normal blockchain, you would still need to decide whose transaction came first and whose transaction came second. If you and me were transacting on the network, and let's say that we press send at exactly the same moment, so it was going into the same block, say on Ethereum or Bitcoin, the network would still decide what order to process those transactions. And it would go, okay, for whatever reason, this validator that's validating this block builder has decided that Piers' transaction is first and your transaction is second. And that's because they have to sequentially process everything. They can't parallel process anything. They have to go, I'm going to do this transaction first, this transaction second, this transaction third. On Radix, those two nothing to do with each other on the network because their data has been mapped to completely different areas of the network because the transaction information, what's being transacted, has got no relationship to each other. So those two transactions can be processed in parallel. So the network doesn't go, oh, Piers' transaction was first and your transaction was second. They just go, were these transactions valid? Are they conflicting with anything that we know? No? Okay, then we will start and end consensus independently of each other so you can have full parallelization. And then as the network scales, then you can have different parts of the network doing different parts of that validation at the same time. That was the first part of it, is now you can, by just making the data deterministic and helping using the determinism of the data, help you make sure that only things that are conflicting are going to need to be processed sequentially. So if I tried to send a transaction from my shard to my mother's shard and tried to send it to another wallet I control, and I tried to send the same money, then the same validators will be involved in validating both of those transactions. And they'll be able to go, no, you're trying to double spend, reject it. So you'll always see double spends, but you'll always be able to process everything that isn't a double spend in parallel. Then you have the transaction manifest, and the transaction manifest is what allows you to stitch many things together. It allows you to go, I want to take tokens out of here, I want to swap with this in this DEX, and then from this DEX, I want to swap with this DEX, and then from this DEX, I want to repay to this account. That transaction manifest is a declaration of all the actions that you want to take during a transaction. And so that declaration is what's used to also pull in any contentious transaction state to coordinate between the validators that are involved in managing that contentious transaction state and be able to sort that out amongst themselves. Again, this is all about making sure that the network has enough information to be able to work out what is contentious and what's not, and otherwise can process everything in parallel. And as a result of that, you can just keep adding nodes because you have full parallelization where you need it, where you still have atomicity and the ability to deal with contentious state where it's declared. And it's always declared because the transaction manifest is required to be able to submit a transaction on the Radix network. So just as a summary on that, the key insight was the majority of transactions on public ledgers do not conflict with each other and have no reason to be ordered against each other. And as soon as you can break the need to process things sequentially, you can create a system that can scale linearly. You have to have an entirely new approach to how you store your data, how you validate your state, and how you submit your transactions to the ledger. And that required a full stack approach to do that, which is again why the Radix has taken the full stack approach, is because that's our secret weapon to enabling linear scalability as well, because it all had to be built in with this idea of cross shard atomicity in consensus.
Yeah, and that would be a perfect end for our conversation. I would love to dig into concepts like Ridyard's DeFi efficiency index and stuff like that. That was yeah, that was a cool one. Yeah, I mean, that was a great conversation, Piers, and thank you so much for taking the time to be here. And looking forward to the Radix progressing to its Xi'an roadmap whenever it comes out. I'm looking forward to it, and looking forward to the cool dApps that are coming on Radix, and keep up building. Thank you.
Thank you very much, and thank you so much for having me on your show.
Thanks for tuning in. If you are keen on getting deeper insights about Web3 tech, our newsletter, Just the Metrics, is just what you need. It's packed with valuable information and it's completely free. You can subscribe by clicking the link in the video description. It's a great way to keep up with the latest in the Web3 space straight to your inbox. And before you go, please hit that like button and don't forget to subscribe to our channel. for more updates and insights. Your support is what keeps these videos coming. So see you in the next video.